Good morning, student. Today we are going to see a new exercise, exercise C, which is uniform circular motion. Okay, let's see C, uniform circular motion. Okay, now when a body moves with a constant speed in circular path, then motion of such a body is said to be uniform circular motion. Okay, when a body moves with a constant speed in a circular path, assume that a particle starts from A and moves in a circular path, okay, tracing this path like this, then we can say the motion of this particle is uniform circular motion. Okay, now here what we find, particle moves with a constant speed. Okay, particle moves equal distances in equal interval of time, right? Means I can say over here, say the particle starts from A, reaches to B, then reaches to C, then reaches to D. In first 5 seconds we can say 5 meter, in second 5 seconds we can say 5 meter, in third interval, in a 5 seconds of third interval it covers a distance of 5 meter. Means it shows us that the particle moves equal distance in equal interval of time. Then we can say the speed is uniform one, right? So particle moves equal distance in equal interval of time, then speed is uniform circular. Uniform. Speed is what? Uniform over here. Now, but at the very same time, we can see that at every instant, this particle changes its direction also, right? So here I can say direction of particle changes at every instant. Changes at every instant. Because of that, so I can say velocity of the body is variable. Velocity is variable. Okay, so we find here the velocity of the body changes at every instant, because at every instant we find that the particle changes its direction. When it is at A, then it is toward the west. When it is at B, then it is toward the south. When it is at C, then we find the direction of the body toward east. And when it is at D, then we find the direction of the body is toward north. Means at every instant, the particle when moving in a curved path changes its direction. So I can say the velocity is variable. And due to variable in velocity, I can say the motion of such a body is accelerated. Okay? So we can say that the motion of such a body is accelerated one. Okay. So this is an ultimate example where the body starts from point A, reaches to B and covers a 5 meter distance in 5 seconds. Then from B it reaches to C and covers a 5 meter in a 5 seconds. Again from C to D, 5 meter in 5 seconds. So we can say that the speed of the body is uniform, because equal interval, in an equal interval of time, equal distances are covered by the body, right? Second thing we find here, the direction of the particle at every instant, at every position get changes, and due to changing this direction of the particle, we can say that the velocity is not constant. Velocity changes at every instant due to changing direction of the body. So we can say that the velocity is variable one, and due to variable velocity, I can say that the body is accelerated one. So there is an acceleration in the motion of the body, right? Acceleration in the motion. Now let's see the difference between uniform circular motion and uniform linear motion. We know that circular motion means the body moves in a circular path. What is linear motion? A body which moves in a straight line path. Okay, so let's see the difference. In uniform circular motion, we find that the velocity of the body is variable, right? Velocity of the body is variable. While in linear motion, we find that when the body is moving from point A to B, then to C, okay? Then what we find over here? We find that the body's direction does not change. Due to no change in direction, here I can say the velocity of the body is constant, right? So, in a uniform linear motion, we can say that the velocity of the body is constant. While the body is moving in a circular path, then we can say the velocity of the body is variable due to changing direction at every instant, right? Secondly, here I can say that body have a accelerated motion because due to changing velocity. What is acceleration? Acceleration is nothing but rate of change of velocity. So as there is a change in the velocity, then we can say that body is accelerating one. So here there is an accelerated motion gained by the body. But in case of uniform linear motion, we find that the acceleration of such a body is zero. Here no acceleration you can find because there is no change in velocity. Velocity is constant, and if there is a change in velocity, then only then we can say the body is accelerated one. So these are the two differentiating points between the uniform circular motion and uniform linear motion. Okay. Now next topic which we are going to discuss is about centripetal force and the centrifugal force. Two types of forces that we are going to discuss. So first is centripetal force. Centripetal force. Okay. What is it? A force acting on the body moving in a circular path toward its center is known as centripetal force. What is the definition for centripetal force? Force acting on body moving in a circular path, toward center of circular path. Okay, toward the center of circular path is known as centripetal force. Okay, centripetal force. So this is the definition for the centripetal force. Means as in that a body is moving in a circular path, changes its position from A to B to C to D. Then we find that this body exerted a motion. Okay, exert a force. Body exerted by a force. Due to that, it moves in a circular path, and that force is exerted on the body toward the center of the circle. Okay, toward the center of the circle. So this way the force is exerted toward the center while moving at every instant, changing direction, its direction at every instant. So this type of force is known as centripetal force. The force is acting on the body, okay, to move it in a circular path. कोई भी body को अगर circular path में move करना है तो उसको एक force लगेगा, and without that force it is not possible. So to move the body in a circular path means at every instant it has to change its direction. So some force is needed, and that force direction is toward the center. So that is known as centripetal force. Okay, this definition is asked into the ICC exam, right? Now let's see an example where we find this centripetal force. Okay, so let's see examples. So first example, an atom. In an atom we can see that there is a centrally placed positively charged nucleus, and around it in an orbital manner the electrons are moving. Actually there is no presence of orbit, but the path tracing by the electron along the nucleus, we can say it as an orbit, which is invisible one. That is not an actual roadway to move the electron around the nucleus, right? So, in an atom, we can say that there is a force of electrostatic force of attraction between the electron and the nucleus, right? What is there in the electron and nucleus? Electron having negative charge, nucleus having the positive charge. So there is a electrostatic force between the negatively charged nucleus and positively charged positively charged nucleus. So because of that, what we find an electrostatic force of attraction between them, and due to this force of attraction, the electron has a pull toward the nucleus. Electron experiences a pull toward the nucleus, which is nothing but a force, and that type of force is known as centripetal force. What is it? A centripetal force. I hope that you understood this example. Second, planets are revolving around sun, right? Now what we can say, the sun is centrally placed into the galaxy, then the different types of planets are there which are at a particular distance from the sun. What is there? There is again, we find a force of attraction, and that force of attraction is nothing but a gravitational force of attraction. Gravitational force of attraction. In the previous lecture only I told you that each body in this universe exert a pull on the other body, and that is nothing but a force of attraction. If the body is smaller than the earth, then it gets attracted toward the earth. When I am throwing the pen, then it comes down toward the earth due to the gravity, because this body is very small as compared to earth. Okay, and that force of attraction formula is F is equal to m1 m2 divided by r square. m1 and m2 are the masses of the body, and r is nothing but the distance between the bodies, two bodies, say A and B bodies. So this distance is nothing but r, right? So by this formula we can find out the gravitational force of attraction between the celestial bodies. So here, due to this gravitational force of attraction between the celestial bodies, this body experiences a force toward the sun. Okay, force toward the sun, and this force toward the sun means toward the center, right? Toward the center of the circular path, which is known as centripetal force. What is this then? Centripetal force. Okay. Third example I can give as Earth revolve around sun, right? Now around the sun, Earth is revolving. Okay, it revolves around itself. That is known as rotation. And when the Earth is rotating around the sun, then we can say it has a revolution. So this both concept you are studying into the geography. They are interlinked. So the Earth revolves around the sun. There is again a force experienced by the Earth toward the sun. Force experienced by Earth toward the sun when it changes its position like this. Okay, Earth changes its position like this. So at that time the Earth experiences a force toward the sun, and this force is toward the center. Actually, it is toward the center of its circular path, right? And that is known as centripetal force. उसको ही हम कहेंगे centripetal force. I hope that you understood all these three examples. Okay, so one more example I can give you, that when you tie a stone by a thread, and if that thread you tie to the stick, okay, this is stone and thread is here. Okay, the stone is tied by a thread and tied to the stick, other end tied to the stick, and when you start whirling it, then you find that it starts whirling in a circular path, right? Now, what is there? What is there which keeps this stone in motion. That is nothing but a tension in the string. That is what? A tension in the string. This is the important. Tension in string. And this tension in the string is towards center. That tension is nothing but what? Force only. Okay? And it is toward center. Okay? So this is again we find a centripetal force in this case. Right? These are all the examples related to the centripetal force. So what is centripetal force? A body which is moving in a circular path experiences a force toward the center. That force is known as centripetal force. Okay? So this much topic, I hope you all understood. Let me see the next topic. Which one is it? Okay? 1 minute. Okay, let's see the another type of force. Okay, this is all about the critical centripetal motion as well as the centripetal force. Now, let's see about the another type of force which is observed by the person who is moving with the body, right? And that is a centrifugal force. Okay, let's see centrifugal force. Okay. What is the centrifugal force means? This is force assumed by observer. Okay. This is a force observed by an observer or assumed by an observer moving with body to act on body in direction away from center, away from the center of circular path, away from the center of circular path. Okay, that is known as what? Centrifugal force. Okay, this is known as centrifugal force. Now, what is this centrifugal force? Centrifugal force. Its direction is opposite to direction of centripetal force. Centripetal force की जो डायरेक्शन होगी उसके अपोजिट, यानी सेंटर से अगर मूविंग कर रहे हैं particle according to the as per the motion of the body in a circular path, his force is in towards center direction, right? Towards center. But one more force is exerted on the body which is away from the center, and that is known as centrifugal force. This force exerted on the body toward the center is known as centripetal force, but the force which is exerted on the body away from the center is known as centrifugal force. Actually, the direction of the centrifugal force is opposite to the direction of centripetal force. Next one is magnitude. Magnitude of both the forces, centripetal and centrifugal, is set. Okay, and it is shown as the magnitude of the centripetal force. It is not real, means it's a fictitious. It's a fictitious force. ये force जो है ये real force नहीं है, ये fictitious है. It is assumed by the observer. जैसे कि कोई एक बॉल यहाँ पे घूम रहा है सर्कुलर पाथ में, यहाँ पे इसको टाई करके रखा है वो बॉल घूम रहा है. If I cut this rope by which it is tied, then what do you find? This ball will thrown away. So one force is there which is throwing it away from the center, and that force is nothing but a centrifugal force, and it is observed by the observer. Okay, the observer who is moving along the moving body, right? So he only can observe this. So that force is nothing but a centrifugal force. It is known as fictitious force. Actually, it is not a real force. Okay. Now here we can say that this centrifugal force is not a force of reaction. It's not a force of reaction of centripetal force. Centripetal force का force of reaction नहीं है. This is important. Okay? This is very important. And the reason is that, what is the reason? Action and reaction does not act on same body. सेम बॉडी के ऊपर एक्शन और रिएक्शन नहीं होती है, जिसके वजह से हम सेंट्रीफ्यूगल फोर्स को सेंट्रीपेटल का फोर्स ऑफ रिएक्शन नहीं कर सकते. ओके, सो दैट इज द रीजन. नेक्स्ट वन इज इट इज I noted it is not a real force, it is a fictitious one. So these are the two types of forces, centripetal and centrifugal. Centripetal body experiences a force towards the center, that is centripetal. Body experiences a force away from the center, that is the centrifugal force. And in the next period we are going to take one experiment. On the basis of that experiment we can see how the centripetal and centrifugal forces acts on the ball. Okay? We come to know in the next video.